Okay, welcome to Let's Get to the Marks. We're looking at alkanes, A-level chemistry walkthrough. This is from the Physics and Maths Tutor website, and it's an MCQ question pack. So this is just going to help you with your knowledge on alkanes. Okay, this is good for AS chemistry or A-level chemistry, Physics and Maths Tutor. Super duper duper. If you ain't using that site, you ain't getting an A star. So let's go. Question 1. Which is a propagation step in the chlorination of methane? Okay, so we've got four choices here, A, B, C, D. We're looking at free radical substitution. Straight away, it can't be C because C involves two free radicals coming together. That's termination. So let's have a look at some of these other possible answers. Right, I got this answer here. I'm going to get rid of this answer right now. So it should be propagation, but what's that hydrogen free radical doing? And I've got another hydrogen free radical here on B. So I could get rid of A and B. There shouldn't be no hydrogen free radical going on. In fact, B, you would have a chlorine free radical attacking a methane molecule, and that is going to create a methyl free radical, CH3, and hydrogen chloride is going to form. So B is definitely wrong. So we look at D, and we got the methyl free radical attacking a chlorine molecule. Then you've got chloromethane and another chlorine free radical forming. So that is a propagation step in the chlorination of methane. 1 mark. Let's go. Question 2, which statement is not correct about the pollutant sulfur dioxide? So you all know about sulfur dioxide. It's released from sulfur impurities in fuels. When they're combusted, the sulfur burns in oxygen to form sulfur dioxide. So can it be removed from a car exhaust? I don't know. Let's have a go look at these. All right. Well, it can cause acid rain. You know that from GCSE. It forms hydrosulfuric acid. Can it cause respiratory problems? Yep. And can we neutralize it using a base like calcium oxide? Well, it's an acidic gas, so absolutely. So which one of these is not correct? Those three are true. So this one is not correct. You can't remove sulfur dioxide with a catalytic converter. Catalytic converters get rid of unburnt hydrocarbons, and they change nitrogen oxides back to nitrogen and oxygen. Okay, which statement is correct about thermal cracking? So it uses a pressure between 100 and 200 kPa. That's a really small pressure because we've got 100,000. We've got, yeah, 100 kPa at room temperature. So yeah, that's not the pressure used for thermal cracking. You need a lot bigger than that, like 70 times. Aromatic carbons are the major products of thermal cracking. Are they? No, they're catalytic cracking. What about this CC bonds are broken? That sounds pretty good to me. Yeah, let's look at, say, butane, right? If we wanted to crack butane, we could make ethane and ethene, an alkane and an alkene. And what you'll find is whenever you're cracking an alkane, you always have to break a carbon-carbon bond, right? You're going to have to smash through a carbon-carbon bond. So, yeah, that's correct. Zeolite catalysts, they're not used in thermal cracking. Of course, they're using catalytic cracking. So, yeah, there we go. Let's move on to question 4 before I start waffling too much. Question 4, which equation, zooming in, represents a propagation step? So remember, propagation must produce a free radical, otherwise it can't be propagation. So this is termination, two free radicals coming together. So A is not a propagation step because it's not producing a free radical to continue the substitution. And B, we got the same thing going on. It's another termination step, two methyls coming together to make ethane. That is not a propagation step. Then we got chlorine splitting into two free radicals. This is initiation. Okay, that's the start of free radical substitution. So the only one that's the possibility for the answer is D, because we have a free radical in the reactant side and a free radical in the product side. That is what you need for propagation. Let's go. Question 5. Zing, zing, zing. An excess of methane reacts with chlorine in the presence of ultraviolet radiation, UV light. What are the main products of this reaction? So, well, hydrogen, nah, that's not formed during free radical substitution. And then we've got, what's that, tetrachloromethane and hydrochloric acid. Well, you kind of need excess chlorine there and you need a different starting hydrocarbon. So again, we're not forming hydrogen, so we can get rid of that one. So we're looking at the one here with chloromethane and hydrogen chloride. And that's the correct answer. All right, let's go to 6. Which statement is correct about fractional distillation of crude oil? You know fractional distillation. That's the thing with the tower and where we're separating the mixture of hydrocarbons. So is a zeolite catalyst used? No, that's catalytic cracking. So zeolite catalyst is used in cracking. You don't need it in a separation technique. That's for chemical reactions. Each fraction contains a mixture of hydrocarbons. Well, yes, that is absolutely true. For instance, petrol, one of the things in petrol is octane, but there are many other hydrocarbons. Gaseous fractions are formed by breaking covalent bonds. No, 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 no. We separate based on the weak intermolecular forces, the van der Waals forces between the different molecules, and obviously the longer chain ones have stronger van der Waals forces. So it's nothing to do with breaking the covalent bonds, and the fractionating column is colder at the top, as we know, and hotter at the bottom. Okay, which equation represents a termination step? So we've looked at these. Let's look at that first one. We've got a free radical on the left and on the right. That is propagation, so get rid of that. Again, B is propagation, so get rid of that. Again, C is propagation, free radical on the left and right. With a termination step, which is D here, we have two free radicals coming together to make an unreactive compound. Well, certainly they form products where you don't have another free radical, so it cannot propagate, it cannot continue the free radical substitution. Okay, that's question 7 done. We're already on to question 8, so let's get into it. Which equation, God, I can't speak, is a propagation step in the conversion of trichloromethane into tetrachloromethane by reaction with chlorine in the presence of ultraviolet light? So we're looking for a propagation step, just to break that down again, nice and easy. Let's get rid of the first one. That's not propagation. Let's get rid of the second one. That's a termination. So we can immediately get rid of that, termination. So really we're only looking at C and D as propagation steps because they have a free radical in the reactant side and a free radical on the product side. And of course you don't get hydrogen free radicals in free radical substitution of alkanes. Okay, God, I couldn't get that bit out. So we're now looking at question 9. Just adjust myself here. The table shows the possible conditions and products for the cracking of alkanes. Which row is correct? So you've got thermal, high pressure, high temperature. So thermal cracking needs about 1,000 degrees. Yeah, okay. The high pressure, you're looking at maybe 70 atmospheres. That's like hundreds of thousands of kilopascals, or maybe not hundreds of thousands of kilopascals, but it's certainly a lot. Whereas catalytic cracking, you've only got a slight pressure, like 1.72 atmospheres, so it's only like 170,000 pascals, so 1.7 kilopascals. It's maybe up to 2 kilopascals. Sorry, 200,000 pascals or 200 kPa. So we're not looking that high pressure compared to normal. It does have a high temperature, not 1,000 as I put there, about 300 to 500 degrees. And the big giveaway for catalytic is that you can form mainly, if you use a low pressure, you can form mainly aromatics. So that is correct. Those are the conditions if you want lots of aromatic hydrocarbons formed. Question 10. Which catalyst is used in the catalytic cracking of alkanes? We've had this before. It's zeolite. That's the zeolite catalyst. Of course, nickel used in the hydrogenation of alkenes, so it's not that. And iron is a catalyst, but used in like the Haber or Haber process, however you want to pronounce it. And concentrated phosphoric acid, we use that one for dehydrating alcohols. So yeah, zeolite's your answer here. Question 11, which correctly represents an incomplete combustion of pentane? So A, B, C, D, they've all got pentane. That bit's correct. What we want to do now is check whether we've got incomplete combustion. And A is for complete combustion. There's no carbon monoxide or carbon in sight. So we want to get rid of A. Definitely wrong because it's complete combustion. And then with the others, they all form carbon monoxide. So they're all incomplete. But we just need to check, are they balanced? So let's check C. We've got 16 oxygens on the left. We've got 4 plus 2 plus 10, 6. 4 plus 2 plus 6. So we've got 16 oxygens there. And then this only looks like 4 plus 6 plus 6. There's only 12 oxygens. So that is unbalanced. The oxygen is not balanced on both sides of B. So that isn't the correct. Let's look here. We've got 6 oxygens on the left. That's 12. We've got 4 plus 2 is 6 plus 6, that's 12. We've got 12 oxygens on both sides. So C, and we've got the same amount of we've got the right amount of hydrogen. 6 times 2 is 12. So why is the bottom one wrong? Because it is balanced correctly. Well, we don't form hydrogen with incomplete combustion. The H2O would form water. So question 12. Which species is produced in the propagation step during the reaction of propane with an excess of chlorine in UV light? So we're looking at the propagation step. What would be formed? You don't form hydrogen free radicals. Um, let's have a little look here. What have we got? What have we got? What have we got? Okay, we've got a load of different molecules. Let's get into this one. There's an excess of chlorine. Sorry, just some bad editing there. Well, the correct answer is C, and let me show you why it is actually C. Well, A is incorrect because of the hydrogen free radical. Already gone through that, but let's look at how C can be formed. Well, the initiation step here is chlorine gets split by ultraviolet light into two chlorine free radicals, and then we've got a whole series of propagation. So the chlorine free radical attacks a propane molecule, and this forms C3H7 free radical. Okay, because one of the hydrogens is snapped off, so it has an unpaired electron, and it forms hydrogen chloride. Now, what we're going to do is take that free radical down to the next propagation step. So we have C3H7 free radical. And remember, we were told about the excess chlorine. So it's going to attack one of those excess molecules. And it's going to form C3H6Cl free radical. And it's going to form HCl again. And then that C3H6Cl free radical is going to attack another chlorine molecule, and that is going to form C3H6Cl2. Yeah, we're smashing through these questions. So let's go. Question 13. Which of these substances does not contribute to the greenhouse effect? Well, unburnt hydrocarbons, things like methane. We know that methane is a serious uh, greenhouse gas. Couldn't speak there. We know that carbon dioxide is a greenhouse gas. We know that water vapor is. Thank God nitrogen's not a greenhouse gas, because 78% of the atmosphere would be absolutely toast. Right, question 14. Which molecule is not produced when ethane reacts with bromine in the presence of ultraviolet light? So which molecule is not produced? That's going to be the hydrogen, folks. You don't produce hydrogen. You sometimes make hydrogen in cracking, but you don't make hydrogen in free radical substitution or halogenation of alkanes using free radical substitution. We don't do that, okay? Okay, let's go to question 17. 17? What? I mean 15. I've lost the ability to count. Okay. Yeah, question 15. As I was saying, sulfur dioxide is produced when some fossil fuels are burned. Which of the following statements is true? Sulfur dioxide can be removed from waste gases in a power station by acid-base reaction with calcium oxide. Let's start at the bottom because the top one's the correct answer. Sulfur dioxide is ionic. No, it's two non-metals. Sulfur dioxide is basic. No, non-metal oxides are all acidic, carbon dioxide, nitrogen oxide included. Sulfur dioxide is insoluble in water. No, otherwise you couldn't get sulfuric acid. Yeah, so the top one, we neutralize sulfur dioxide using calcium oxide or calcium carbonate. We spray it on the flue, which is the chimney of power stations, to remove that sulfur dioxide. Right, 16. Tetradecane is an alkane found in crude oil. When tetradecane is heated to a high temp, one molecule of tetradecane decomposes to form one molecule of hexane, three molecules, and three more molecules. So this is really key to answering this question, is highlighting. Which of the following could represent this reaction? So you really just want to check, do they all have a molecule of hexane? Okay. And then are there three other molecules there? And then is it balanced? So you can see if we start at D, we have got a hexane, C6H14 formed, and we do have three other molecules, right? So that's beautiful. Now we just need to check, is it balanced? And so we just, we got 32 hydrogen on the right and only 30 on the left. Yeah, it's not balanced. So let's look at C. Right, we have pentane over here. It asked us for hexane. So it doesn't form hexane. So immediately, no need to check if it balances. It doesn't match the target of the question, that it was supposed to form hexane in three more molecules. So we can get rid of C. Now let's look at B. B does form hexane, big tick. B does only form two more molecules. Look, it's hexane and it's C6H12 and C2H4. So that is only two molecules. That's not three more molecules. So again, we don't need to check if it balances. That's incorrect. And that just leaves our lovely correct answer, which is A. And we can just make sure it's correct. Look, it forms hexane, beautiful, C6H14, that gives a big tick. It does form three other molecules, C4H8 and two molecules of C2H4. So that gets a big tick as well there for the three more molecules. And then also, if you add up the hydrogens and carbon on each side, they balance. There we go. All right, guys, once again, like, share, subscribe. Let's get to the marks.
You're
Thanks
still
for watching.
here? It's over.